Hello, my name is Russell Coburn. I'm the Chief Executive of Durham Magneto-Optics, and we manufacture the MicroWriter, and this is our MicroWriter ML3 product. And I'm just going to give you a quick demonstration of how to load a sample, do a simple exposure, and just use the machine in its everyday mode. So the first thing we need to do is to put a wafer into the machine. So all you do is you press this button here, and that moves the wafer chuck towards the loading position. It takes a few seconds, the light flashes while that's happening. When it arrives, the door unlocks, and we can then open the door and put the wafer on the chuck. So I will just get a sample. So this is just a die with photoresist on. And we'll open up, and it's a friction chuck, so there are no vacuum pumps. Instead, there's a ground glass surface which is sufficiently rough to hold the sample in place. So there we go. To have a look at that. So there's the sample just in the middle of the chuck, and that chuck can take up to 200mm wafers. And then we close the door, and we press the button to lock the door again. So now we need to focus on the sample, so we need to enter an estimate for its thickness, which is going to be about 550 microns. And already you can see bits of dust. This is a microscope that shows you the sample surface, and if I click, then I move the sample surface. So our estimate is roughly right, but now if we press the autofocus button, that will do a precise focusing and measure the exact thickness of that sample. So this takes about 20 seconds to focus. Okay, so we estimated 550 microns, the system says it's 540, so that's fine. Now, depending on what I want to do, maybe at this stage I want to align the wafer so that I expose my pattern in a precise place on the existing wafer. If that's the case, I can use the microscope, and I've got a system of markers that allow me to identify different parts on the wafer and correct for rotation, stretch, shear, all those things. This isn't a precise exposure, I don't really care where it is on the wafer. I'm just going to move slightly away from here because there's a big bit of dust in the centre there. So we'll move to there instead, and then I will centre the wafer there. So that's set the origin at that point. So that's us done. The next thing is to design the pattern. So in this case I've used professional mask design software, which we can supply with the machine, to design a chip that looks like this. This is a standard sort of test chip. So this is about 4mm square, this whole chip. And this is saved as what we call a CIF file, a CIF, which is the standard vector format for the machine. So let's load that in. So I create a job. So this is the job list, and this is the list of all the different things that are to be exposed. So the first thing to be exposed is that file with our test chip. And so we load that in, and I can choose details about which resolution I want to use, which beam size. If I've got multiple wavelengths on the machine, I can choose which wavelength. I've got lots of different exposure modes, normal, vector, grayscale. I'm just going to use normal for this. And also there's a quality setting which is to do with exactly how smooth those edges are to be, but we'll use normal settings. If it had been a multi-layer file with different layers, I could select from here which layer I want to expose. But in this case it's layer 0. So that's the definition of what I want to expose. Then I go to the expose panel, and I tell the system what sensitivity the resist is. So probably the value here, 65 millijoules per centimetre squared is fine. And then I click go. So the first thing it does is it's going to make a very simple map of the surface profile to look for any slope on that surface. So it's going to take 3 points. There's the first point. And it's going to do an autofocus at each of those points. So this will take about 1.5 minutes to do the whole procedure. Once it knows the exact surface height at those 3 points, it can fit a slope through those, and then every point on the surface will be perfectly in focus, even if the wafer is not flat or if it has some curvature. So you see on the narrative here, it's a Z correction -5 microns. So it's decided that that point is 5 microns higher than the place where we autofocused. So now it moves over here. So that point is +5 microns, so there's a very gentle slope. Hardly worth worrying about, but the system likes to get the precise slope. And here's the final test point down there. Okay, so it's done, and now it starts the exposure. So the purple rectangle, that's the field of view that it's exposing at any one time. It exposes 1 million pixels, all in parallel, and it's in a serpentine fashion rastering that exposure area across the whole of the chip. And there we're done. So about 20 seconds to expose the whole of the area. So we then open the machine back up again. So the door unlocks and the wafer the sample has come forward so we can take it out. And we take it out of the machine. And now I'm going to go and develop this, and then we'll bring it back and use this machine as a microscope to see what we've got.